How inappropriate is it to call this planet Earth when it is quite clearly ocean? Wonders a scientist. True, 70% of our Earth is covered by oceans, and consequently 70% of our natural resources are available underwater. Humankind needs to harness this wealth while preserving the beauty, the splendor, the life forms and the natural ocean characteristics. From the shallow waters at the coast to the deep waters and tropical regions to the polar areas, the resources vary, and so do the technological challenges. While man was able to reach the moon, knows a lot about the surface of Mars, the ocean next to us is still left largely unexplored due to its vastness, tremendous forces that it creates, and the sheer fury that it churns up at times. In the southern part of India, there exists an institute called the National Institute of Ocean Technology at Chennai in Chennai, which has taken up this challenge of developing suitable technologies for harnessing the ocean wealth in an environmentally friendly manner. The Department of Ocean Development, now the Ministry of Earth Sciences, established the National Institute of Ocean Technology in November 1993 for developing and demonstrating technologies to promote underwater applications consistent with a nation-building exercise in marine infrastructure. Some of the programs NIOT effectively implemented are coastal engineering, offshore structures, desalination, marine biotechnology, ocean observation systems. Deep sea technology, submersibles, ocean electronics, marine sensors, ocean observation systems. Ocean acoustics and vessel management. Energy and fresh water from the sea. Desalination. 97% of the water on Earth is salt water, leaving only 3% of fresh water, of which about 2/3 is frozen in glaciers and polar ice caps. The world's supply of fresh water, though a renewable resource, is steadily decreasing. Desalination of seawater holds the answer to it. NIOT has been working on desalination using the ocean thermal gradient. The surface seawater at about 28 to 30 degrees Celsius is sent to a low-pressure flash chamber where it instantaneously evaporates under vacuum. The generated vapor is then sent to a condenser where it condenses to water using colder deep sea water at about 12 to 13 degrees Celsius. The low-temperature thermal desalination (LTTD) technique was successfully demonstrated at Kavaratti Island of Lakshadweep Union Territory. It is a great achievement for NIOT, as a fresh water supply from the plant has significantly reduced the incidence of waterborne diseases like diarrhea and the prevalence of hypertension and renal diseases. Further, towards scaling up the technology for mainland requirements, NIOT also commissioned an experimental floating barge-mounted LTTD plant off the Chennai coast with a capacity of 1 million litres per day. NIOT has also successfully commissioned and has been operating the LTTD process at NCTPS, utilizing the huge amounts of warm water discharged continuously from the plant. Currently, efforts are on to transfer the technology to the industry for putting up such plants in islands and power plants. Design of a large capacity offshore desalination plant is also in progress. Wave energy. One form of renewable energy from the oceans is wave energy. A pilot plant based on the oscillating water column principle was commissioned at Vizhinjam in Kerala during 1991, successfully demonstrating that wave energy could be converted to electrical energy. NIOT is now working on a small floating wave-powered device called Backward Bent Ducted Buoy for remote locations. Other forms of ocean energy using currents and temperature difference are also being pursued. Offshore Structures. The aim of Offshore Structures Group is to provide innovative design solutions through continuous research to cater the needs of the Institute programs like desalination, mining, data buoys, and offshore industry. Major activities of the group are development of technologies for offshore structural components, island desalination, establishing LTTD-based plants in Lakshadweep Islands, demonstration of shore protection measures. Suction piles are the predominant mooring and foundation system used for deep water applications. A prototype pile of 3-meter dia and 4.5-meter long was successfully demonstrated off Dabhol in 20-meter water depth. It is proposed to establish state-of-the-art numerical offshore tank facility in the Institute to simulate non-linear response offshore structures and installations for varied environmental conditions. Thus, a physical and technological infrastructure consisting of offshore wave and current basin, dynamic simulator, multi-body dynamic analysis software, 3D visualization facility, and high-performance computing system. The first demonstration desalination plant was established in Kavaratti Island of Union Territory of Lakshadweep in May 2005. Based on the performance of the Kavaratti plant, UT administration has requested NIOT to take up 8 more plants. 2 more plants in the Agatti and Minicoy Islands were commissioned recently during 2011. The technical achievements in design and execution of desalination plants in Minicoy and Agatti are: the plant is fully automated and requires minimal intervention. Concrete sump weighing 300 metric tons was cast in lagoon and taken to site in floating condition by traversing a distance of 15 kilometers, which is a unique operation carried out by Institute. Substructures and wave breaking area were designed for monsoon waves and executed at site with simple equipment. The Institute has specialized in the design and construction of deep-sea submarine pipelines from water depth of 400 meters to 5 meters in environment of high ocean currents and waves. The seaside of the pipe is weighed down and lowered to about 400-meter water depth. 2 coastal sites that have been potentially facing the erosion and siltation problems were taken up for demonstration based on the request from local authorities. The current studies aim at developing environmentally friendly shoreline stabilization measures using field measurements and numerical modeling. Both studies have been completed and final recommendations are being sent to local authorities for its implementation. Deep sea technology and ocean mining. The deep ocean has abundant mineral resources like polymetallic nodules, cobalt-rich manganese crust, and hydrothermal deposits. The polymetallic nodules containing manganese, cobalt, nickel, and copper are viewed as potential resources to meet the increasing demand for these metals worldwide. India has a status of pioneer investor and has been allotted a site in the Central Indian Ocean Basin by the International Seabed Authority for exploration and technology development for polymetallic nodule mining. Deep Sea Technologies and Ocean Mining Group of NIOT has been actively involved in development of technology for polymetallic nodule mining from 6,000-meter water depth. As a first step towards development of underwater mining system for mining manganese nodules at 6,000-meter water depth, an underwater mining system operable at 500 meters water depth was developed. The underwater mining system is a crawler-based system which moves on the seabed under remote control from the mothership at top. The crawler has been designed to operate on the soft seabed and has special track belts with involute teeth to compact the bed during motion. Pumping operations were tested at 415-meter depth successfully. The crawler was subsequently augmented with nodule collector and crusher system, and its performance was demonstrated at 500 meters. Based on its performance, the system is being upgraded for 6,000-meter water depth for nodule mining. A fully electrically operated, remotely operable subsea in-situ soil tester was realized and tested at 5,462-meter water depth in the proposed first-generation mine site at Central Indian Ocean Basin during October 2011 for assessment of soil properties in situ and delineation of the seabed. Cone and shear vein testing was done on the seafloor to ascertain the extent of bearing area required for crawler tracks for operation with minimum sinkage, which in turn will aid to optimize the design of mining machine. Clear videos of nodule resources showing the abundance and topography of the sea floor were also recorded through underwater video camera. The Coastal and Environmental Engineering Group focuses on the development of capacities and technical services for sustainable coastal infrastructure. The group specializes in handling projects for coastal investigations, hydrodynamic modeling, sedimentation studies, coastal observations. Presently, the Coastal and Environmental Engineering Group has been entrusted with projects such as Sustainable Shoreline Management, Technical Criteria Atlas, HF radars. Sustainable shoreline management aims at developing technologies for eco-friendly shore protection methods along with demonstration at select sites. Technical Criteria Atlas envisages developing an engineering design reference for environmental parameters like sediment transportation rate, current, tide, and waves. The atlas covers the entire coastline of India, including islands. The group is also responsible for providing studies and services in the areas of site investigation, planning, engineering design, environmental impact assessment for coastal development projects like harbour, power plant, etc. The resources include the latest equipments and laboratory facilities for bathymetry, geophysical, geological, geotechnical, environmental and oceanographic surveys. The group has undertaken a number of investigation projects all along the Indian coast since its inception. One such major project being implemented now is called Kalpasar project, which aims at construction of a dam across Gulf of Khambat in Gujarat. This project includes extensive field observations and numerical studies to prepare the detailed project report DPR. Coastal and Environmental Engineering Group installs and operates HF radar network along the Indian coast. This network is capable of providing continuous observations of ocean surface currents over an area of more than 10,000 square kilometers. The group thus strives to excel in the fields of coastal observation, engineering investigation, and engineering solution related to coastal space. Submersibles and Gas Hydrate Group of NIOT is involved in development of deep water systems in ocean exploration and harvesting deep water resources. A deep water remotely operable work-class submersible, ROSUB 6000, has been developed by NIOT. ROSUB 6000 comprises remotely operable vehicle, tether management system, launching and recovery system, high voltage, high frequency power conversion and transmission system, data telemetry and acquisition system, integrated navigation system, control and operational system, and scientific payloads. The submersible, rated for 6,000 meter depth of operation, is equipped with multifunctional tools and sensors for offshore applications such as seabed imaging, pipeline routing, wellhead detections, sampling, deep water exploration, etc. The first exploration sea trial was conducted during October 2009 in Krishna Godavari Basin at gas hydrate site in Bay of Bengal. First design depth qualification trial at Central Indian Ocean Basin was successfully conducted during March-April 2010 using ORV Sagar Nidhi by testing all the subsystems for its envisaged functionality at the maximum depth of 5,289 meters. Indian tricolour was dropped by NIOT at these depths, and India joined a select club of nations. NIOTians promise to take you to new depths every time. As a part of its quest for the alternative fuels and achieving energy security for the nation, Ministry of Earth Sciences has initiated a program for the exploration and study of the gas hydrates. Gas hydrates are crystalline forms of low molecular weight hydrocarbons, which has attracted attention as a future potential energy resource. NIOT has been given the mandate to develop technological tools for the exploration of gas hydrates. One of them is a deep water autonomous coring system being developed by NIOT in partnership with Williamson and Associates, Seattle, USA. Operational trials of autonomous coring system are in progress in Indian seas. Ocean acoustics. Ocean acoustics is the study of sound and its behavior in the sea. The group is focusing on the research, development and implementation in significant areas of underwater acoustics. A totally indigenous automated ambient noise measurement system with a vertical array of hydrophones, data acquisition system, subsea floats and marker buoy has been developed for time series noise measurements and deployed in shallow waters along the east and west coast of India, and voluminous amount of acoustic data have been collected which are helpful in detailed acoustic characterization. The system has been operational in shallow waters of the sea at a few locations during pre-monsoon and monsoon period, and continuous data over 3 to 5 months, including extreme events such as Jalak and Thane cyclones, have been collected. The system proved its stability by being operational during cyclonic events. An underwater Ethernet cable has been incorporated into the system to transfer high-frequency data sets from subsurface data acquisition system to surface buoy. This was successfully tested in shallow waters off Chennai for 10 days, and easy data recovery was achieved. The time series data enabled the understanding of seasonal variations of noise, noise-influencing sources such as winds, rain, and biological species. Patent for the system is under process. The group also executes inter-institutional projects by collaborating with IITs, IISc, and CSIR labs. Projects in significant areas of acoustics such as underwater acoustic signal processing, sound propagation modeling, seabed characterization, and object detection unit for divers are being carried out. Marine Sensor Systems was established in NIOT with a mandate to develop and demonstrate underwater sensors-based technologies for oceans. Needs of NIOT projects are unique, and to meet these requirements, specialized facilities are required. Many electronic support facilities like helium leak detector, climatic chamber, corrosion test facility, shock and vibration system have already been established, and more facilities are in the pipeline. NIOT has taken up the task of developing non-off-the-shelf underwater components and subsystems in association with Indian industries, 250 kilowatt underwater motor, single-mode fiber optic connector for deep water application, subsea power systems, to name a few. Underwater acoustic transducers form a vital element of most of the underwater instruments. NIOT has developed an expertise in design and development of acoustic transducers to suit various underwater applications. A lightweight 19 kg, 1 kilowatt, 2 to 18 kHz transmitter has been successfully developed and tested in field, interfacing with standard systems. The Marine Sensor Systems Group is currently developing acoustic systems for shallow water ocean bottom mapping and imaging applications. The group has also developed user-based sensors and transferred the technology TOT to industry for production. Marine sensors and systems based on the user needs are also being developed by Marine Sensor Systems. The group has many publications and also filed applications for patents for the products developed. The Ocean Electronic Group has been formed to focus on technology development in ocean observation and ocean systems. The group is currently concentrating on the development of deep ocean pressure recorders for tsunami warning systems, profiling drifters, surface drifters and autonomous underwater sea gliders. The profiling drifters are fitted with CTD sensors that profile up to 2000 meters water depth and transmit the data through satellite after completion of each profile and descend again back to their parking depth for the next cycle of operation. The periodic profiles of the temperature and salinity would enable better understanding of the ocean circulation, enhance climate predictability, and validation of satellite data. The group has developed a deep ocean pressure recorder system with new tsunami detection algorithm. The laboratory trials have been completed and the system is undergoing deep water trials. The group is also working on INSAT-based communication system for observation systems. Marine biotechnology is one of the emerging tools to exploit the vast marine bioresources in a sustainable manner. A number of technology development activities on the biochemical and biotechnological fields are being addressed for exploring and enhancing marine living resources at the state-of-the-art laboratory and farm facilities created at Chennai and at the Andaman and Nicobar Islands. NIOT has successfully developed bubble column reactor, tubular photobioreactor and solar-powered raceway systems for mass culture of marine microalgae in order to produce biofuel and nutraceuticals such as lutein, phycocyanin and astaxanthin in pilot scale. Genetic engineering approaches are also underway towards the enhancement of biofuel production. Further, the group standardized electroflocculation techniques to harvest microalgae. NIOT has also successfully isolated microorganisms from deep sea water and sediment samples. So far, 125 bacterial and 48 fungal strains have been isolated and purified for testing against various human pathogenic microbes and biofouling organisms. High-pressure, low-temperature serial dilution and fermenter systems for deep-sea microbial isolation and cultivation at in-situ conditions were designed and developed. As part of the drug development program, around 700 samples of marine flora and fauna were collected from Andaman and Nicobar Islands and screened for biological activity. So far, the group has identified 60 potential samples which are positive against cancer, HIV, tuberculosis, diabetes and anti-inflammatory properties during preliminary screening. Towards enhancement of marine living resources, 9-meter dia HDPE cages were designed, fabricated and deployed with multi-point mooring system at Olaikuda, Kottachatram and Port Blair. Culture of sea bass was demonstrated in these cages. As part of the endeavor to enhance the livelihood security of the coastal poor, the group designed, fabricated and deployed oceanic fish aggregating devices off Lakshadweep and Andaman Islands with considerable successes in attracting fish around them. The group also designed and deployed artificial reefs at Odisha coasts which attracted large numbers of reef habitants, including big fish such as groupers and sweet lips. The Andaman and Nicobar Centre for Ocean Science and Technology and COST at Port Blair is working as a technology transfer and support platform in the Andaman and Nicobar Islands for the Marine Biotechnology Group and other groups of NIOT. The Ocean Observation System's erstwhile National Data Buoy program was established in 1996 with the prime objective to operate, maintain and develop moored buoy observational networks. Moored data buoys. The data buoys are offshore floating platforms fitted with meteorological and oceanographic sensors moored at specific locations to observe in situ met-ocean data at regular intervals. These buoys are powered by batteries and are equipped with GPS to provide the buoy location. Time series observations are vital to improve the understanding of ocean dynamics, variability, and are used to monitor the marine environment and to improve weather and ocean state forecast. The Omni buoys are moored buoy network in northern Indian Ocean and are more similar to data buoys but have the capability to measure ocean current, conductivity and temperature up to 500 meter depth and transmit hourly data through satellite. In addition, these buoys are also equipped with radiation sensors and rain gauges too. The Omni program addresses a long-standing need to understand the observed variability of upper ocean thermohaline and current structure on several time scales that have bearing on the evolution of monsoon and cyclones. These buoys give new insight into understanding of recent cyclones. The tsunami buoys. As challenges arise in the form of natural disasters, OOS is now entrusted to deploy buoys capable of identifying tsunamis as part of Tsunami Early Warning System in India. OOS team has developed, tested and has established Tsunami Buoy System and BPRs in Indian seas. The Tsunami Buoy systems consist of two units, a surface buoy and the bottom pressure recorder BPR. Communication between BPR and the surface buoy is established through acoustic modems. The observed data from these moored data buoys and tsunami buoys are transmitted through satellite along with location information once in 3 hours to the state-of-the-art shore station facility at NIOT Chennai. The shore station is manned 24/7 and the data obtained from data buoys and tsunami buoys are disseminated in near real time to Indian National Centre for Ocean Information Services in Kois, Hyderabad for further processing. The program's achievement is only a step, though a substantial one, on its long march towards a societal cause. Vessel Management Cell manages the running, operation and maintenance of 5 vessels by outsourcing various services. Technical management and overall control, program planning and implementation is done in-house. Ministry of Earth Sciences acquired 2 coastal research vessels, Sagar Purvi and Sagar Paschimi, during 1996. To manage these 2 vessels, MOES established the Vessel Management Cell at NIOT. The vessel Sagar Paschimi was commissioned in November 1996 and Sagar Purvi in December 1996. The vessels have been specially designed for coastal oceanographic work. During 2006, VMC acquired new ocean research vessel Sagar Manjusha for deployment of data buoys and for other scientific activities of NIOT. ORV Sagar Nidhi joined NIOT fleet of vessels. This vessel is India's most sophisticated research vessel, specially built for technological demonstration in deep sea. The vessel is versatile ocean observing platform equipped with technologically advanced scientific equipments and related facilities. The vessel is fully automatic diesel-electric type equipped with azimuth thrusters, improving the behavior of the ship in rough seas. Sagar Sangamam Conference Centre is NIOT's commitment to provide a common platform for like-minded scientists and engineers to meet and freely exchange ideas and concepts that will benefit the world community. The group maintains the state-of-the-art Acoustic Test Facility ATF, which is continuously accredited by National Accreditation Board for Testing Laboratories NABL. Upgradation of ATF has been achieved by increasing the frequency range of calibration from 100 kHz to 500 kHz. The facility is used by DRDO labs, IITs and other national research institutes for testing and calibration needs. Also, the ATF caters to the testing purposes of all the acoustic-based systems developed or used by other groups of NIOT. Hyperbaric Test Facility at NIOT is the first of its kind in India. Testing in this facility saves a lot of time and money for qualifying underwater components which otherwise would have been by actual testing in the sea at that depth. Hyperbaric Test Facility is used to simulate the pressure in deep sea environment inside a high-pressure vessel. The facility has been designed to test components at an external pressure up to 90 megapascals, which is approximately equal to 9,000 meters of water depth. NIOT Library is well equipped with modern facilities and resources to provide the research community with technical information needed to achieve its objective. Ocean, the inner space, holds the key for the human survival on planet Earth. Rapidly increasing needs of India, the nation on the move, can be met only when the resources from the oceans are sustainably harvested. NIOT, the modern mariners, strive to help the nation in achieving the security in water, food, energy, industry, coastal protection, climate change, capacity building, and human resource development.